Hello everyone, our project is on bias and data availability study in healthcare. Here is our Gantt chart. It is showing all of the tasks that we completed during our project, and it shows that all of them are 100% completed, so we have concluded our project. Typically, we see that health outcomes are reliant on available data. However, since data bias exists, it does not always reflect the true population. And for our project, we use the US Census dataset to get an accurate representation of the United States population with limited bias, and compared that to a heart disease dataset collected in Cleveland, Ohio. We examine age, gender, and pain level bias in the dataset. And here are our team members.
In this slide, I use a Tableau to show the male and the female ratio with respect to the chest pain. So we can see that the male has a lot more identifiers that record for different types of chest pain. However, for females, we are lacking a lot of data values for level 3, level 2, and level 1 chest pain. Here is the male-female ratio versus the exercise-induced angina. So this graph pretty evenly show the distribution between male and the female. However, on the level 1 here, male has a less data sets compared to the female data set. On this graph shows the male to female ratio with respect to the ST depression induced by exercise relative to rest. We can see that female has way more data set compared to the male data set.
So here we see the exercise-induced angina, and this is sorted by age, and this is only showing male participants. So as we can see, there is a decent amount of data being shown for the males. However, when we go to the females, there is not much data that is being presented for exercise-induced angina. Now here we go on to chest pain for men. This is also sorted by age. And here we see that for the type 1 chest pain, there are no men with this type of chest pain. And there is barely any data for the rest of the types of chest pain. However, when we go to the female chest pain by age, we see that there's a decent amount of data, but still not enough. So here we can conclude that there's some kind of bias based on gender and age. Here to the left, we see that the distribution of age is more centered around ages 50 to 60. And the figure to the right shows the difference in male to female given the age groups. Therefore, we see that there are a lot more men in each age group except ages 70 to 80. And given the heart disease data set, it is assumed that heart disease is more likely to happen between ages 40 to 70.
In examining this dataset, we have discovered that the women who were included in the dataset were far more likely to have heart disease than women who were not. Exactly 75% of women in the dataset had heart disease, while the men in the dataset were more split down the middle, with 45% having heart disease. The women participants, whether or not they had heart disease, were older on average in this dataset than the men by roughly 2 years. The total average age of all women participants was 55.7, while total average age of men participants was 53.7. Men who had heart disease had it at an average age of 50.9, compared with women who had heart disease at age 54.6, almost 4 years later than men. Since the data set shows heart disease shows up earlier in men, this gives the impression that heart disease impacts men more than women. Curiously, the gap between those who had heart disease and those who did not was wider in men than women. In this data set, men have an average difference of 5.2 years compared with women at 4.4 years.
In order to identify the database using the AIR Fairness 360, we select our part attributes, age, and the gender. And we are going to focus on the disparate impact and equal opportunity fairness matrix. From result, we can see the disparate impact, both of them are less than 80% because we use the 80% rule. And so the bias exists in the age and the sex. And so we are going to mitigate the bias using the revetting method. The reverting method is a pre-processing mitigation algorithm, and they can transform the data to have more equally in positive outcomes on the protect attribute for the privileged and unprivileged groups. And here, the result shows after using the reverting method, the age become fairness enough, and you can check the disparate impact is equal to 1. And for more details, you can check in our documentation, and the code implementation can be found in our GitHub repo.
Today I'm going to talk about how we identify bias with disparity. So the disparity is a way, is a term that describes that the difference between the cumulative distribution difference between variables. So in here that we can see the graph that we're trying to understand that what is the difference between the genders such as male and female, and you can see that the max disparity is like 0.27 and is around like 34% of population. So if we want to minimize the disparity and also like the bias, then we want to kind of like make the disparity smaller and move the green line toward the right side. The way that we mitigate bias is using a research model that find the trade-off between the disparity and AUC. The AUC is an indicator that how good the predictive model it is. So by doing that, we can find out that the model 20 is the best one that we can find. And further that we found our results shows that we are able to move the green line toward the right side and also having a smaller disparity in our final results.
Along with doing the analysis on the publicly available data that is available for healthcare research, we also did some study on the data collection process that is out there, which is used to generate these data. And any techniques that can be applied to improve these data collection process that can generate a better quality data and which can have a fewer bias. So broadly, data can be classified into quantitative data and qualitative data. Qualitative data are generally comparatively more complex or more harder to avoid bias. So these are some of the techniques that you see on the slide. You can find details about all of these techniques in the report. With this particular research, our hope is that this will help the data collectors to design a better data collection process so that it can generate a better quality data for healthcare research, which will have fewer bias.
We identified that the heart disease dataset did include some bias given that we compared it to the United States Census dataset. We found that there was age and sex bias. The dataset is very outdated and only contains limited data in Cleveland, Ohio, so no real health outcomes should be deduced from this dataset. For future plans, we plan to analyze more datasets and do a literature review to conduct more conclusive research, and we want to apply different debiasing and mitigation techniques. Thank you all for listening to our project.